On today's episode of WatchJRGo, we are here with an air compressor, and a big air compressor. This is the kind of air compressor you see running jackhammers on the side of the road, or the guy that winterizes your sprinklers. He's pulling one of these. What is going on, guys? I'm WatchJRGo, and today, like I said, we are here with a giant high volume air compressor. And the air compressor is actually tiny, isn't it?
Yeah, I wouldn't, there's bigger units than this, a lot bigger. This is only 185.
But this is what everyone rents.
Right, this is one of the most common ones.
Yeah,
right,
absolutely. But it's honestly very tiny. So this is a dual rotor,
dual vane, dual rotor, just like a supercharger. And this is the oil separator tank. This is the gear drive for the compressor.
Oh, listen to that! And you can hear it ripping air through.
You hear it ready to go. Anyways, this thing, I bought it. It only had 110 hours on it. And I didn't look at it. The guy said he had it, and said it had 110 hours on it, like new. I said, so sent one of my guys down to get it, and he started it up, and it ran, so he shut it right off. And then he towed it home.
Okay.
And then we hooked it up to the sandblaster, turned it on, and it ran for about 10 minutes and blowed all the water out of the radiator. So
it looks pretty heartless, right?
Yeah.
So we've got the engine out.
This thing looks a little old, but it's been around here for a long time. But it actually was nearly brand new when we bought it.
Yeah.
And I can tell why he put it up for sale.
Right, it was overheating on him.
Yeah, and they had already done a lot. So they'd put a new water pump on the engine. They had changed thermostats. They put a new, they've been going through it trying to fix it. Couldn't figure it out. So they put it up for sale.
And apparently, they also put new hood struts on it.
Yeah.
Look at that. It holds it up.
I think those are original.
Are they original?
Yeah.
What year is this?
I don't know. I never looked.
Must not be terribly old.
It's not terribly old, but you can see right over here in the controls.
Yep. Is there a year?
There's your hours.
180.
180. So I maybe it was 170. We only ran it for a few hours. I was thinking it was 110, but it's like new.
Yeah.
Anyways, they obviously unloaded it because nobody could fix it, so he put it up for sale. I'm the sucker who bought it.
Well, I don't see any year on the nameplate there, but.
So anyways, we bought this engine, this thing, and the first thing I did with it, this is all the parts. This is all the parts out of it. We're gonna put it all together.
All right, so we got this 4-cylinder diesel engine here, right?
Yeah, it's a little 4-cylinder Perkins.
Yep.
Made in UK.
Okay.
And so these parts have all been cleaned. There's the crankshaft. Okay, this must be the head. So we'll be careful, it's all clean. There's the head.
Drop the dirt in it.
So we sent the head out. Yep. First thing I did was I sent the head out and had it checked. And they pressure tested the head, said there's nothing wrong with it. So I brought it back, put it back on, put a new head gasket on, started it up, 10 minutes, all the water come out. I mean, as soon as we started it up, it was bubbling in the radiator.
Yeah.
So I had the guys tear it back apart. I sent the head back over to the guy who's working on it because we couldn't see nothing wrong in here.
Yeah.
There was absolutely nothing wrong in these cylinders. I mean, we couldn't see a thing.
I mean,
look at this block.
Yep.
I mean, the block looked
brand new.
It looked new. And couldn't find nothing wrong with here. So I sent him back. He checked it again. And he said, Ross, he said, I guarantee you there is nothing wrong with that head. I was disgusted with it at this point. We had plenty of other stuff to fix. I said, just pull it over in the storage building and get rid of it. We'll come back to it when we got time. Let her set. Well, it's set for a year and a half, 2 years, I'm not sure. Finally, we got done with the project, and the guy said, hey, I need something to work on. I said, well, go over and get that compressor, bring it over, and let's get to the bottom of it.
Yeah.
He brings it over. This is the water pump in, so here's number one, this is number one.
Okay.
And he brings it over, and when we tore it down, we didn't drain no antifreeze out of it, so it was level full with antifreeze right to all the coolant holes.
Okay.
Like right there.
Yeah, sure. It was
setting level full with coolant. Don't hurt nothing, just sit there with coolant in it, right? But when we rolled it in and looked at it, we looked right back here. This is number 4. We looked in number 4, and about right there was a giant rust star.
Ah.
It looked like a snowflake. So it bloomed out with perfect shape, just like you were looking at a picture of a snowflake.
Yeah.
It was a hole in the cylinder.
Sure.
And it was down to where it was about yay far. You know, this piston was down at bottom dead center. So it was about yay far up, but it was enough up that when the piston had come up, it put up enough pressure that was coming up to push air out through that hole.
And into that coolant passage or whatever
Yeah,
right there.
into the water jacket.
Yep.
Caused it to bubble. So, what do we do? I don't know if you can see it or not, but if you look real close, I sent it over to a friend of mine, and he sleeved it.
Okay, I can see the sleeve. You can see a little.
You can see the sleeve mark there.
You can see pretty obviously the color changes
So
around it.
I had him sleeve it, and that's been a year ago. And
It is pretty dusty. No, you can see the sleeve from the top.
there's a sleeve. Sleeve didn't come all the way down.
Oh, okay.
Oh, there it did. There's sleeve. Came
looks
down
like-
there, but it didn't come all the way down here.
Looks like he even put a couple welds on there to hold it in.
Probably some Loctite or something in there on that bore. So he pressed it in, put it in, and I know he didn't hit the deck because this is outside the head gasket.
Right.
So you can see that's just surface rust.
Right. If you hit it with a fly cutter, it would have cleaned up.
Yeah, it would have. So he would have cut it off. So he just, I don't know how he did it, but he cut that right down without taking anything off the deck.
Huh.
So, anyways, the deck's ready. So, anyways, that's the story. So,
As long as you can't feel it, I guess.
Yeah.
Probably good.
so I'm not changing the bearings.
Yeah.
I just bought a ring set for it. So somewhere here we'll have to. Oh, it's right over here. There's a ring set, gasket set. I'm putting the original bearings back, and we're going to build up the crankshaft and put it back together and get it in there, and finally have an air compressor that's ready to use. Or we rent air compressors here too. So
Yeah.
So it's either going to go into the rentals or we'll use it here if we need one.
But this has the weirdest main bearings of all time.
Yeah, this is quite well. It's not. It's the way they build them all today. But this you can see the crankshaft. Look at them throws.
It is pretty.
And the main race.
Yep.
Throws and the main race. They're all they're brand new.
Yeah.
So we're going to give this another final wash. But yeah, the way this crankshaft is made is the bearings are made such that each bearing is a different size from the one before it. So in other words, this is on wood. So I'm just going to set her down right here.
They step down.
So this bore is bigger than this bore, which is bigger than, you can see it's tapered.
Yep.
So
It's got like this infinite hallway thing going on there.
yeah, so it's really cool for fast assembly. So somewhere, wherever Perkins is putting this things together, there's somebody building up the crankshafts, torquing the main bearings. Then all you have to do is throw it in the hole and put the pins in, which keep the bearings from spinning.
Yeah.
It's pretty neat. There it is. There's a bearing.
Yep.
So I'm not changing that bearing,
Yeah.
I mean, if I put a brand new bearing in it and run it for a couple hours, it'll look just like this.
Yeah, that's true.
Right? Maybe if you run it for 100 hours, but I could probably spend another $100 and put brand new bearings in it, but
It'll also probably run for 5,000 hours before it needs
yeah.
it.
I probably won't have it that long, or probably won't care.
Yeah. Yeah.
Yeah, if we can get this bathed up, get the crankshaft in, put the bump stick in, and get I think all the timing, it's going to be easy to do on the front. There's still a little bit of dirt in here from the machining
Yeah, I saw.
when he machined it.
You can see it sitting in the cylinder.
Yeah, so we'll give out a good bath, blow it out. This thing has roller bearings on. It has roller bearings on the bump stick.
Yeah, I can see it. You can just
No.
see the edge of it through the whole little slot.
Yeah, I don't like the looks of that bearing. to tell you the truth.
does look a little gross.
Looks like something left over from the.
Machining.
Yeah, see that white? I don't know what that is.
Oh yeah, that's definitely high, whatever it is.
Yeah. Yeah, I think it's part of his whatever he put in on that sleeve before he
to
pressed it
hold
in.
I see.
Because he wanted to make it a watertight seal. See,
Right.
you can see where he bored right down to there
Yeah.
and stopped. This is the original bore.
Look, those are welds. That's not locked.
No, that's some kind of a sealant.
Is it?
Yeah, I can cut it with my fingernail.
Oh.
He put a sealant in there so that because it was water leaking behind it.
Right.
So he didn't want any water to come out. The old boy that does this, he's about 80 years old, and he does a great job. Okay, so it looks good. So tonight we'll get the solvent sprayer, give it a good spray, get it all cleaned up. We might entertain changing this bearing.
Well, we already ran into the first roadblock. We just need a jackhammer to take it out.
Well, I tapped out the concave flat plug. And there I found my first. That is from leftover from that steel.
Yep.
Leftover cast iron. Leftover from the bore job. So that's what I wanted to see.
Yep.
So yeah, that bearing's not going to move. So we need to tap that guy out of there.
It might move.
It probably would, but we need to blow the.
Yeah.
Before we roll it, I'd want to take all the stuff out of it. It might be damaged, So,
yeah.
But these others, they obviously got rusty. So what we're going to do is we're going to come through here with the camshaft driver, and we're going to drive these two bearings out because after looking at them just now, they're too rusty. Looks like that might work. How's that fit up against there? Just like it was made for.
It actually looks like it fits pretty well.
Now, here's a big hammer. I think, isn't that a hammer?
I mean, it's heavy.
Catching it?
Yep. Halfway. That was all the way.
All right.
Ooh, look what else fell out. That was exciting. Oh. Well, it's like a glue they use to set the bearing for the factory.
Yeah, that's just green bearing lock.
Yeah.
And that looks like a 6205. What is it? Or 6203. Oh, no numbers.
No numbers. That's not good.
We'll have to measure it.
Off to BRC. This bearing did come back to life after we drove it out. I gave it a little bit of well, you kind of grip the side, give it a turn after we knocked the dirt out of it, and it's alive, but it sounds absolutely terrible. So that's going in the trash.
Okay. Okay. Hold it.
See it moving.
Okay. Okay. Go. Go. You're about to get her out. Okay.
That was it, right?
No.
Oh, it's
Yep, that's it.
Okay.
Okay, there's your bearing.
How does it look?
It's the gift that keeps on giving. There could be little pieces of steel or cast iron out of the cylinder that would be down under that bearing, which would be catastrophic because as soon as you start it up, you'd wipe this bearing out.
Yeah.
This
Cam would lock up.
This is the bearings, the only bearings that I've been worried about. So I'm going to have to order them, but you got that one loose.
Yeah, that one's, I mean,
Ooh, boy, it's got a nice notch in it.
Isn't it notchy?
Yeah.
It's got some speed to it now, but
I still see steel in it.
Yeah.
See, there's a piece right down there.
I see it. Big and shiny.
If we can't, I know. Unlike those inserts and the mains and I mean, you clean them, you can see them. They're perfectly clean.
Right.
With these, we couldn't. So let's get this last bearing out of here. I'll get these coming tomorrow. So what I'm having you do is just hit right there on the end.
Right.
I mean, I'll get a cam bearing installer to put it back. I don't have one because I don't do it often enough. I usually just have somebody else do it for me. Nope. Okay. You were almost out. There you're at.
You can't say we're getting fast at this. That's when it all falls apart.
Yeah, I should have kept my mouth shut. This bearing, of course, is smaller than its partner.
Yeah, because these are also size after size stacked up.
Look at that rust.
Yeah, it was pretty rusty.
Yeah, see, that's because it got washed out and wasn't lubed. I mean, it's been sitting around here for years, though. So, I mean, it should have been sprayed down with lube. When I told him to wash it with solvent.
Is this the one you said wasn't? We couldn't read the marking on? 451. It is 4516.
Yeah.
It might be 8, but the 6 looks. Oh, it's 8. I don't know. It sure is tough. I don't know if you guys can see.
Which one is it?
It's like the 6.
It's got to be on both sides. Here, I'll just rub a little grease off my. Come on, light. About time for a new light.
Well, this
4516.
4516. That's what we thought. The ID should be 1.7 inches. That's all we need to do is check that. 44 millimeters. And then this one's clearly a HMK 4520.
Okay, so now we can come back and do a good clean. I want to do a solvent wash through all the bores, and this might be
6203.
It's a 203.
Yeah.
That's what I thought, 6203. This is the pressure relief, and see how it squirts in right there? See that? Your pressure?
Oh yeah, I see it.
We're going to take that out, so we need to unscrew that. This will be on the water. So we'll give that a good flush, but we need to see there's oil's gonna come out right there
Sure.
into that bearing, and that's a bearing. Okay, so I definitely don't want trash coming out of there.
Well, unfortunately, we got to get those 3 bearings. The plan was to have this whole bottom end assembled tonight, so we had a long block ready to go back in the compressor, but unfortunately, we're not just a quick wash away from putting it back together. We got to get those 3 bearings. Luckily, they're here in town, right? Won't BRC have them all, probably? Maybe. They might have them.
Yeah, the 6203, that's no problem.
Yeah, but the roller bearings are maybe...
Those are super oddballs.
Ah.
That's probably something that has to be ordered.
Well, they're not expensive, I can tell you that, because I did look up the first one. It was $17.99.
Oh boy, we could buy a pair.
Yeah, we put 2 of the same ones in it even.
We should get a spare and just go ahead and leave it here with the engine.
Yep. But we'll get those bearings coming, and then we're gonna put this thing back together. You guys can see it makes some high volume air. And then I guess we start you're instead of a rental company, a sprinkler blowout company.
No. No.
That is it for today, guys. Thank you so much for watching. Don't forget to head on over to shop WatchJRGo.com for cool shirts, not like this. And please,
That's
like,
a cool
share,
shirt right there.
do whatever you want to do.
Favorite shirt.
And I will talk to you next time. What else you want to play with over here?
Well, I got this.
Plasma cutter?
No, it's a DC drive.
A DC drive.
Yeah.
Not a VFD.
Not a VFD. Nope. Before VFDs, there was DC drives. And the guys were welding with our rotator
Yeah.
the other night.
Your rotating positioner?
It's just a pipe roller.
Oh.
And the pipe roller
And it quit rolling?
gave up.
Huh.
So we gotta fix this dude.
Really?
So, yeah, so what we're gonna do is I had them bring it in here so it'd be
In the heat.
plenty of light and I could sit down and use my thinking cap. So this is a dart, which darts have been around for forever if people know DC drives.
What's this motor? 12 volt?
No, that's a DC. That's a DC. So on a DC drive motor like this, to have the high torque, it has a field that's based on a couple of different voltages. If you're 120 volts in, you're either 90 or 180 volts. I think this is a 180.
Oh. So this is like a variable transformer with some kind of rectifier or something like that?
A little before your time. Let me explain it. This is 90.
90 volts.
90 DC armature.
Yep.
And a 180. That says 180. It's been hit by something, but that F means 180 volts field. So you have 4 wires coming into this motor, right?
Okay.
4 wires. 1, 2, 3, 4. That ground is being used as a conductor, but that's the factory cable it came with. So.
And it's on like a twist lock outlet? I see.
Well, the guys did that for me, so I get it apart. But the way that motor's made is just looks like a generator, right? But you come in, you got a field coil on one side, like right here, and that wire goes over to the other side and rolls around and comes back out. So you got these 2 wires out right here. That's one of these. That's one of this pair, right?
Okay.
So this is the field, and it'll have the shoes. These are called shoes that are right up against the side of the armature.
Instead of brushes?
No, you haven't got to the brushes yet.
Okay.
These are the shoes.
Gotcha.
Right? So this is called the field. So if you looked at it, it'll look something like this. Right?
You're talking about the magnetic field looks like
Yeah,
that.
exactly. Yeah. Just like when you take the guts out of a starter, you can look down and you see the fields, right?
Yeah.
Okay, so this is the fields, and this is like F1 and F2. And you just put 180 volts across there and it makes a strong north power. You know, one's a north,
Right.
one's a south, right? Then you got the armature that fits back in here. And the armature, right, comes out, and it's got brushes.
Right here.
Right there and right there. Well, that's these other 2 wires. We call this the armature wires, A1 and A2. Okay?
Yep.
So if you put 180 volts on the field on this motor and 90 volts on the armature, you'd run full speed.
Okay.
And this is
Incredible
very
high torque.
powerful little motor.
Yeah.
I would imagine that may be a 1 horsepower motor.
Huh.
Which
Oh,
is-
look at it. Oh, no, it says amps. I thought it said HP when I looked real quick. I was like, 1.5? Wow.
1.5 amps. That's probably the amps on the armature.
Yeah.
So anyways, so what you do with these is you leave 180 constant on the field and you vary the voltage to the armature.
Uh-huh.
And so by varying that voltage, it varies the speed of the motor.
Okay.
So unlike a VFD, which is in these cabinets we're building,
That changes the frequency.
changes the frequency on an alternating current
Yeah.
motor. So this is the thing of the past. When I was a kid growing up, this was it. When I was your age, no, I was 10 years, 20 years younger than you.
Yeah.
This was about the end of the era, and variable frequency drives were just coming in. And today, that nobody knows DC drives.
Right.
Only reason.
VFDs are so cheap.
Well, yeah, they're cheap. Yeah, and for years, a variable frequency drive couldn't produce the same torque.
Ah.
Oh, there's a wire.
Is that that's the whole problem, isn't it?
I doubt it.
It's definitely that one.
They've had this thing apart, so I need to get the old.
That one's your forward brake reverse switch.
Yeah. So right here you can see here's this is our wires going out right here.
Yep.
So this will be the armature, and this will be the field. And there's power coming in right there. So all we got to do is plug it in, see if we got power on the field, and if we got 120 on the field, then we got to find out. You know, the rest of the electronics is strictly for adjusting the armature voltage, and then what we do here, this forward and reverse switch just reverses the polarity of the voltage going to the armature.
Gotcha.
So by reversing that, it runs one way or the other. Obviously, this has got to be fixed for it to work.
What are all these fine tuning pots? Oh, that's
Every one of
kinda,
those pots does something
That's
like
kind
it.
of cool. Min, Excel,
Yeah,
decel, max.
that's right. So minimum speed, how fast does it accelerate? Then how fast is it allowed to change? When you make a change here,
Yeah.
how fast do you let it accelerate? Today they were all done in seconds, but back here, it's still done in seconds. But back here, you adjusted a voltage to get it done.
Yeah.
And Excel,
It's just ramp
decel.
up and down.
Yeah. So here's your minimum. I think that is going to be minimum speed, maximum speed, Excel, decel. Here's your current limit. So this sets out, because this thing may be able to put out more current. It may be bigger than what this thing allows. So what you do is you put it at full speed and you adjust this so that you don't melt the motor down.
Gotcha.
So setting the current. And then IR, that's, you know what IR stands for, right?
Resistance? Internal resistance?
Almost. What's I times R?
I don't remember. Current? Voltage? One of the two, right?
Yeah, it's one of them two.
One of the two. That's the rest of the equation.
Voltage.
Well, okay,
Right.
okay.
Right. If
Yeah.
you take you take your current and pass it through the resistance.
You'd
Right?
think they would have just printed volt on the circuit
Well,
board.
it's actually a
It's not really.
it's actually a current limiter.
Gotcha.
So, okay, use 120 volt. Now I've got the wiring diagrams for this in my office, so I need to go to my office and get a meter.
Yeah, you need a meter for sure.
Let me go get the diagram.
Did they
So-
got all the hertz out of it?
Well, what happened
All
was
600 of them?
yeah, what happened is this is the variable frequency drive that adjusts the frequency. You put 3-phase or single phase in, and you always get 3-phase out. You can see how they ruined it. This is a brand new drive. They
Yeah.
ruined that screw.
It almost looks like it melted though.
No, that's just that's heat sink compound or just oxyband
Gotcha.
that keeps you from your wires from oxidizing. Not necessarily on something like this, but obviously they ruined that screw.
Yeah, it's gone.
So since it was brand new, it had never been ran. This was a brand new drive. Had never even had power applied to it, and since we're the factory authorized service center for it, I kind of had to dissect it.
I see.
You can't see it, but this was actually in here somewhere. I don't remember where. You can see I cut it, but see all these little pieces? See all them? There was a great big integrated circuit that was soldered into the back of this. It came in from the back, and they wanted me to keep that piece. They shouldn't have, but they wanted me to. I would have just bought one because it was $150.
Yeah.
It cost me more than $150 to save it.
Oh, I bet.
And so we had to, because you have to unsolder it. Well, when you unsolder it with something this big and this heavy, what I did was I had to destroy this board to get it out. So I just took the right angle grinder with a cutoff wheel, and I cut the board in two, and I cut it down to all these little bitty pieces that I could unsolder just two at a time.
What do they want you to save? Is it a set of
wanted me to-
MOSFETs or a...
Yeah, it's isolated gate bipolar transistors. It was a mess to cut this all apart.
I see.
I usually have an IGBT right here that we're working on. So it was a piece that looked like this, only instead of having bolts,
Yeah.
it had 32 pins all the way around it that were all soldered into the back of that board.
Yeah.
And
Because this is from a much larger drive.
this is just one IGBT.
Out of a
This whole thing, this is one great big IGBT.
Gotcha.
What was in that one was all there's 6 IGBTs. That's isolated gate bipolar transistor, or insulated gate. Every frequency drive has 6 of them.
Sure.
This is so power. This is out of such a big high amperage one that they put 3 of these modules in.
You just switch all the I/O really fast, and you get whatever hertz you want out of all of them.
Yeah, it switches the transistors on and off at 4,000 times a second.
Yeah.
In most drives.
Right.
And so what it does is by turning, it's just a switch. It's on, it's off, on, it's off, and by turning it on longer, you get a higher voltage. So so it turns it off just a real short pulse, and then longer pulses to make it real tall, and then it comes back down. It does that. It's running at 4,000, so the switching is 4,000 hertz, but it
Divided by 3, right?
well, it makes each one gets turned on 60 times a second.
Okay.
It makes a 60
if you're
hertz
putting out
wave
60 hertz.
if you're putting out full speed.
Gotcha.
And you can slow that way down. So there's all kinds of VFDs around here. There's one, I don't know what's going on with that one. We got another brand new one we picked up today. Oh, this one over here blew up. This is variable frequency drives that we're
We got
putting.
the big ones for the pump. And
Yeah, the big one's a pump, the little one's a blower. This one just came in. It's a P7, and this one probably got hit by,
lightning.
probably got stopped working. I don't know what it is, but we checked it out and found out I think their input diodes got blown up, so they probably got struck by lightning. That's the number one thing that kills them.
Yeah.
And either that or people, fill the fans full of debris,
Yeah.
and, or the fans just don't get serviced. This is obviously, look how dirty it is. I mean,
It looks like it's been in Oklahoma. It's got some red dirt on it.
the dust don't hurt it, no.
Yeah.
The dust don't hurt as long as it don't get completely filled. But this one, normally that's what blows them up is the high voltage hits the input. What does that normal solder look like?
Normal solder is, I don't know, 015 or whatever, instead of the most precise solder on the planet for this big old wire.
It's all made out of the same thing.
Yeah. You're gonna be feeding it in there so fast.
Don't breathe in
Hey.
fumes. Make all your babies be born naked. That's what Dad used to tell me.
As opposed to in Ralph Lauren.
Yeah, that's right. Of course, Dad didn't know who Ralph Lauren was. Okay, so we'll give that little guy right there a little solder.
That's a lot of solder. What a huge ring terminal. Gonna have to feed it in there. You need a positioner to feed the solder into the positioner.
Ain't that bad. How's that?
I don't know.
I can't see it.
It's not globbed on like the factory joints. You need to do some globbing. Lights burn out on your soldering iron.
Yeah, I got 2 more today.
2 more soldering irons?
No, that too, but I didn't
Oh.
get them today. But
Oh.
no, I got the lights today out of an old one.
Guys, we plugged this in just a minute ago too and started doing some testing already. And the relays were clicking in, but it still wasn't moving, so it wasn't that
Okay,
wire.
so on. Yeah, that's forward and reverse.
Yep. Switch works.
Okay, so let's just put it in forward. Give it some speed, and let's see if we got field voltage. So should we have AC or DC?
DC.
Right on.
I mean, it's a DC drive.
Just checking. Well, so we got 120, and we got no field. That's where we start. Do we have any armature?
Nothing.
Nothing. So, let's reverse it and see if it's pulling in any relays.
Things change. Nothing. Just zeros.
And here we have the diagram. So here you can see we got AC coming in. That's just AC 120. That's P13. So this will be your inputs.
Mm-hmm.
So that's AC coming in. Obviously, there's a fuse underneath here. I see it right there.
Oh.
Don't want to touch it. I might get a little sparky
You might.
since it's plugged in. So you got AC coming through that on-off switch right there. That's this switch. Is that switch? It's got to be that switch. Okay. Then here's AC2, AC1. We can see that comes over here. There's one of the field terminals.
Yep.
Okay, the other field terminal has got to be somewhere around here.
It looks like they might not have
About-
identified it, but field minus is right there.
Yeah. So that's going into right here.
Field minus 2. Yeah.
They're just showing you that that's a reference mark. Here we got AC again right here. Okay, so the transistor that fires here, this is the workhorses right there. This is one, and this is one. That's a silicon controlled rectifier. Okay, and so when you turn that SCR on, the speed with which you turn that on. Okay, because we got all AC current coming in, their AC voltage, so they're going to commute. So it's going to come down when this goes positive, it'll flow through here, out, go through this one, and go out. And then when you're going through the other side of the sine wave, it'll feed through this one, come down through here, right over here, right, go through here, and go back the other way. So that's how your AC is turned into DC, is by firing these two guys to get it to run. Of course, obviously, you see this is a freewheeling diode. So this is going to be your plus. Yeah, there it is. Armature plus, armature minus. So that's how you get your plus and your minus out. So what's firing these? You can see it's this network right here. That little R17, the 180K. It's coming over here, coming down here, coming over here, coming right here. So this little op amp right here, when it turns on, it's going to pull this voltage up or pull it down. See, I got 12 volts coming in right there. So it's either going to pull it up or pull it down, which biases these three resistors, this one, this one, and turn that on. There's your max current, right? That's the one that says max up there. So it limits. And here's your IR compensation. Okay, so this is compensating for the current and the resistance through the system. I call it IR comp. So anyways, what we got to do now is start out and figure out where we're losing it. So we got to see if we got 12 volts. This card right here is a separate card.
Oh yeah.
And I found this one.
Oh, because what's it do? Because there's another armature output right there, right?
Yeah, exactly.
Gotcha.
So this is putting the voltage. Hey, wait a minute. Why ain't that tightened down?
Oh, it
See that?
feeds into it.
That's got to be tight.
Well, what if that was it?
No, that wasn't it. Couldn't be that simple. Maybe it's on.
It is on.
Okay,
Nothing.
Let's see what we got. Nothing.
Nothing.
Still nothing. Okay, so we got to find out something broke in here. So first thing I'm going to do is pull this circuit board out.
Why don't we just probe that fuse while we're in there? Because the fuse is on the AC side.
There's two of them in there.
Oh, well, we got relay switching. It's not the fuse.
Right. We know we got AC power.
Yeah.
Let's take that out. So the SCRs are mounted there
Oh, to the heat sink.
to the heat sink
Yeah, I see.
to get rid of all the heat produced by their switching, because they generate a lot of heat during switching.
It's crazy. This thing rolls some pretty big pipe over, I guess, right?
Yeah, we've used it for quite a while. It don't owe me nothing, but you know, it's $1,000 to buy the card. I thought, hey, well, at least I ought to look at it.
Yeah.
See if I can, you know, not like we had something else to do. This is the 12 volt voltage regulator. It's just a little 3-terminal device that puts out 12 volts. Says it's number Q2.
Q2.
Found Q2. So there it is. And this is the filter on the output of it that's right here. This filter is what steadies your, takes the ripple out if there is any. So we go right here and see if we got 12 volts.
Nothing.
Ruh-roh. No 12 volts. So why do I have it turned on? I do.
Yeah, I think it's all on.
All right, so then we back up to
The transformer?
D14 and D15. That should be these big guys.
D14's right there.
Oh, watch your finger.
On top of the transformer. I'm watching.
D14 is?
Yeah.
There it is, and there it is. So what that does is that's going to put out DC. Where's D16? You see D16? He might be easier here, but we're not getting anything out of this guy.
Yeah, 0.
We got nothing. I think we found the problem.
Just a bad transformer.
That
Primary.
guy right there is bad.
Huh. Well, at least that's a $3 part, right?
Yeah, well, maybe $1,000 part. Where's your screwdriver at? Okay, so now I want to take this out.
This screwdriver?
We'll take this out and look underneath it. See how bad it is. We got AC, you should have AC right here,
Yep.
right? So what I want you to do is take that voltmeter, okay? And I want you to test right here and see if you got the 120 going into the transformer. If I throw it down, you'll know I got shocked.
I figure you're probably not throwing it down at 120.
Yeah. Okay, so first you got a 120 VAC. Okay, test them two right there, and what you got?
Nothing.
Nothing. Ah.
You think we got 120 there? Yep, we sure do.
You got it right there. Yep. So, let's see, we know that one's coming down to this side. What we got to do is figure out the path. We know this is one side of the transformer. This side right here is going, that must be on top of the board. And the way you figure that out is you take my little flashlight, which is on right there. Okay, hold your flashlight.
I'm gonna unplug this.
What's the
oh, yeah.
What's the fun in unplugging it?
You can kind of see. You can't really see where that trace goes though. Power's on. 65 volts negative.
Look there. So we are feeding it. Now put that on AC and see if it's
14 VAC, 6 volts AC.
That's a capacitor charging up.
Ah.
Okay, so we should have voltage from here.
75.
Yep, and we should have it here to here. Yep. So what we're doing is we're not, the SCR is not turning on. So this SCR is what's giving up.
Ah.
The SCR pack. So it's being told to fire, but it's not firing.
Huh.
So we got to unsolder that and see if we can find it. Go ahead and unplug it.
You're off.
Well, we've narrowed this down to this SCR, probably, but Dad's got his...
He said he had a diode checker, but he showed up with a 6-volt flashlight.
It's for checking SCRs. It's a homemade deal my dad taught me how to make. Hey, 5 volts.
Yep.
Okay, so that'll work. So now, this is a little deal my dad used to make these. So I showed my employees how to make them, and they love them. It'll check any SCR. If I connect black to white, this should be coming on. This wasn't one I built. This is one of my employees. I just got to find out how he made it work. Our battery was dead, so we just took the bulb out of the mag light. Now when you take them apart,
It'll shut off.
should shut off. Okay, so what you do with these is you're going to put one red here.
On AC2.
Don't matter, yeah.
And the
Put
other
that there, and then we'll put this one down here, right? And when you strike 8, it should turn on.
Yep.
And see how it stayed on?
Yeah.
Strike the gate.
Nothing.
Okay, let's reverse these leads.
Nothing.
Hey, look at that.
One side's dead.
One side dead. Let's go back and test the other side. I know people can't see what we're doing here, but
Here. Now they can.
this is minus. And so what you do is a silicone controlled rectifier, once it's turned on,
Stays on.
it stays on until it commutes. So
We lost our power.
gang up all 3 of them together, just in case you got a bad connection. Yeah, there you go. So put that on there, flash your red. Okay,
Yep.
now see how the gate turned on once you,
Stayed on.
now you should be able to do the same thing on that side.
And it doesn't.
It doesn't do it.
It's dead.
Okay, so that's our problem. Go back and test the first side again just to make sure.
Thermal compound all over me. Yeah, it's coming on.
Why is it not?
It is.
What? It's not.
It keeps lighting and then we lose connection like right there.
Well, guys, there you go. That SCR failed, and we think it's because
The thermal compound failed.
caused it to overheat and it just smoked itself inside. So that's the end of that drive. You can still buy this SCR today for $94, which is crazy. But the drive's $1,000, so there's that.